Let's solve an integral that requires the first trig identity that we discovered last time. So remember, that first identity was cosine squared of theta is equal to 1 minus sine squared of theta. And remember, this lets us transform a difference, this thing right here, into a single thing squared. Okay, so let's solve the integral square root of 9 minus x squared divided by x squared dx. Okay, so the 9 minus x squared is the thing that we want to transform because that difference is making the integral very hard to solve because it does not cancel with the square root. So let's do the following. We'll say let x equal 3 sine of theta. So the 3 is a little bit new. We didn't really discuss that before. But the purpose of the 3 is so that when you square it, you have a 9 in both this term and this term, which means we can then factor it out and take the square root of it. So if x is equal to this, then dx is equal to 3 cos of theta d theta. Essentially what I did is I did the derivative of x with respect to theta, which is just 3 cos of theta. And then I simply moved the differential down here over to this side of the equation. That's how we get this. Okay, so now let's transform the integral. So inside the square root, we're now going to have 9 minus 3 sine of theta squared divided by, so the other x squared also gets replaced. It's going to be 3 sine of theta squared. And then your dx gets replaced with this. Three cos of theta d theta. Okay, so now let's simplify as much as we can. So if we square everything that we've substituted, we'll get 9 minus 9 sine squared of theta. And then on the denominator, we're going to have 9 sine squared of theta. And then this still will be here, the 3 cos theta d theta. Okay, now in the expression underneath the square root, we have a 9 in both terms. So we can factor that out. So we continue down here. We will get integral of the square root of 9 times 1 minus sine squared of theta. Divided by 9 sine squared of theta. And then multiplied by 3 cos theta d theta. Okay, so the 1 minus sine squared of theta, that's where we're going to use our trig identity. That's going to be equal to cosine squared of theta. And we can also just take the square root of that 9. Because if you have the square root of a product, it is the product of the square roots. So we get 3 times the square root of cosine squared of theta, because we replaced the 1 minus sine squared with cosine squared, all over 9 sine squared theta and then multiplied by 3 cos theta d theta. Okay, so that square root and the cos squared are going to simplify, and so is the 3 and the 9. The 3 and the 9 is going to be a 1/3. And actually, if you have a 1/3 here, that's going to cancel with the 3 here, so all of these constants actually cancel out. So let's get rid of those, and we'll also get rid of the square root. So we're going to have cos theta over sine squared. And since all the constants canceled out, we just have a cos theta d theta over here. Okay, now cos theta times cos theta, that's obviously cos squared theta. Over sine squared theta, d theta. Okay, now the temptation here might be to write this as cotangent squared of theta, because the definition of cotangent is cosine over sine. However, that will not help you. Instead, what you want to do is you want to replace the cosine squared of theta using, you guessed it, this trig identity again. It seems kind of weird to like go in one direction and then the other direction, but the point of doing it the first time using this identity was to eliminate the square root. And now we've already done that, so it's okay to go back to a difference. We actually want the difference here, so we're going to replace the cosine squared of theta with a 1 minus sine squared theta. And you'll see that that will help us significantly. So we have 1 minus sine squared of theta over sine squared of theta d theta. Okay, well, if you have a difference in your numerator, then you can split that into two separate fractions. So we can split it into 1 over sine squared of theta minus sine squared of theta over sine squared of theta, which that's just going to become 1. And 1 is a very easy thing to integrate. Now 1 over sine squared theta, that is equal to cosecant squared of theta. And the antiderivative of cosecant squared of theta is negative cotan of theta. And then the antiderivative of negative 1 is just negative theta. And then we have a plus c, our constant of integration. Okay, now the thing is, we don't just want to answer in terms of theta, because our original question was in terms of x. So we need to replace all of the theta expressions with x expressions. And that is where a triangle is going to help us. So we're going to build a triangle based on our original substitution, which was this, x equals 3 sine of theta. We're going to use that to figure out the sides of a right triangle. That will help us transform from theta back to x. So let's do that. So let's draw our triangle right here. And let's put our original substitution here, which was x equals 3 sine of theta. So if you solve for sine of theta, you will get sine of theta equals x over 3. And the reason we do that is because now we can use SOHCAHTOA. This is the SO from SOHCAHTOA. So if this is theta right here, and this is our right angle, then the opposite is here, which means we put an x there. And the hypotenuse is here, which means we put a 3 here. And then using the Pythagorean theorem, we can solve for the remaining side, which would be 9 minus x squared. And it's no coincidence that this was actually in our original integral. If you look back, you'll see that in the numerator we had the square root of 9 minus x squared. This will happen very often on your triangle at the end. Okay, well, we're trying to replace the cotan of theta. Cotan is 1 over tan, and tangent is opposite over adjacent. So that means that cotangent is just adjacent over opposite. So that means it's this over this. So we can replace the negative cotan of theta with a negative square root of 9 minus x squared over x. And now to replace the theta, we just use the inverse sine function here. If we apply inverse sine to both sides, we will get theta is equal to arc sine, which is the same as inverse sine, of x over 3. I prefer the arc sine notation because it's less confusing than sine inverse, in my opinion. Okay, so we subtract arc sine of x over 3. Then we have plus c, and this is the answer. So the conclusion is the integral square root of 9 minus x squared over x squared dx is equal to negative square root of 9 minus x squared over x minus arc sine of x over 3 plus c. And there you go.